Hey everyone, so today I'm gonna be going over the problem 5 for the 2025 F equals MA exam. So essentially, this problem tells you that there are 3 cylinders stacked on top of each other as shown here. The centers of the cylinders connected forms an equilateral triangle, and the frictional constant between the top and bottom cylinder is mu1, and the friction between the bottom and cylinder and the floor is mu2. And the question asks you which of these pairs of mu1 and mu2 will allow the system to remain in static equilibrium. So first, we do a free body diagram for the bottom cylinder. And it's drawn here. So we have the force of gravity, so mg, and we have N1, which are these, and these are the normal force exerted on the top cylinder by the bottom cylinders, and the frictional forces are shown here, and these are the friction. These are the friction between the top and bottom cylinders, and the frictional force acts this way instead of down, is because the reason that this is because the top cylinder has a tendency to slide downwards, so the frictional force kind of opposes that motion, and thus the static friction will act toward the top. And so from this free body diagram, we get this equation right here. And now we do a free body diagram on the bottom cylinder. So, for the bottom cylinder, we have the weight of the cylinder mg, as well as, according to Newton's third law, the frictional force from between the top and bottom cylinder and N1. And we also have the normal force from the ground N2 and the frictional force from the ground F2. Alright, so from this free body diagram, we can first get the equation for the vertical in the vertical direction. So in the vertical direction, we get this equation. So N2 is equal to this. And horizontally, we can do the same thing, and we get this equation. And to balance, and finally, if we look at the torque exerted on the bottom cylinder, because the normal force goes through the pivot, the weight acts on the center of mass of the cylinder, they don't exert a torque on the object. So only the frictional forces exert the torque. And so if we take this point as the pivot, the center of the cylinder as the pivot, then we get F1 times the radius is equal to F2 times the radius. From this equation, we get that F1 is equal to F2. So now we have 4 equations and 4 constants that we need to solve for. So we have the unknowns are N1, N2, F1, and F2. And we can just solve a system of equations. So the system of equations is shown here. And what we can first do is to try to solve for N2, because we notice that if we add equations 1 and 2 together, we get that N2 is equal to 2/3 mg. And if we do a little bit of algebra with equations 2 and 3, then we can get this equation. And so because F1 is equal to F2, we can substitute F1 in for F2, and now we get this equation. So, and finally, we try to get rid of F1 to solve for N1. And so we subtract the equation 1 from equation 5. and we get this. So now we know that N2 is 2/3, 3/2 mg, and N1 is 1/2 mg. And so now that we know this, we can solve for F1 and F2 just from equation 1, right? So now we know that F1 is equal to F2 and is equal to this number. And now we know mu1 and mu2, so the range for mu1 and mu2, right? Because the static friction has to be less than this number. So we can solve for mu1, which we get is around 0.268, and mu2 is approximately equal to 0.0893. And if we look back at this set of numbers, we know that only the second pair works. So if we look at the problem, then we know that answer B is correct.